The figure on the left side describes to us how a program is run in a computer. So, as I have already demonstrated to you in the previous video, first your C program or your source code will be compiled and executed in the computer, of course using a compiler. And once it is running, the computer, as it executes the program, it asks for input data, and the computer would process the input data to obtain the output data or the desired result. Now, if we are going to zoom in, what's happening inside this box in the computer, this is what you can find, what's going on inside the computer. And that is described to us by the broken box in here. So actually, you first open or run the compiler. Like in our case, we use dev C++ IDE. And once dev C++ is running, we then type in our C program or our source code to dev C, and then we compile it. Now remember again that the job of the compiler is to translate the high-level programming language source code into low-level object code. And this low-level object code will further be translated or interpreted by the internal system of the computer. And at the end of the compilation and translation by the internal system, once the true executable code is generated, the one with the file name .exe, that is the true machine code. We call that the true machine code or the true binary code, which is in the form of ones and zeros. Once it is generated, then the computer executes that or run that machine code. So it is the true executable code or the true machine code, the one with the file name extension .exe. It is the one that is being run and executed, not the original source code. Okay, it is this one, the true machine code. And once it is running, it then asks for input data from the user, and the computer will use that input data to obtain the output data of the program or the desired results. The ideal program design process involves two phases. The first phase is called problem-solving phase, and its result is a working algorithm for solving the problem. This problem-solving phase is being represented in the figure as the left broken box. And the second phase is called implementation phase, which is represented by the right broken box. As depicted in the flowchart here, the input to the problem-solving phase is a programming problem. Okay, so again, the input to the problem-solving phase is a programming problem. And the first step in the phase is to clearly define the problem. Programmers need to have a clear understanding of the problem, because if programmers don't clearly understand what the problem is, what are the necessary inputs, what are the necessary outputs, and what are the necessary computations and formulas to use, then most likely the programmer cannot solve the programming problem. So again, a clear understanding is needed. And then once the programmer clearly understands the problem, then the next thing to do is to design the algorithm, just like what we did in our previous lecture videos. We design the algorithm. This is like your draft solution to the programming problem. After that, you do desktop testing. Desktop testing is just like manual testing using paper and pen or whiteboard and marker. You like go over the algorithm step by step, follow the algorithm step by step or the flowchart to check if all the steps are correct and the order of the steps or the processes and the tasks or the instructions are correct, and you're using the correct formulas and many other considerations. So this part here is a cycle, because if during the testing you discover some errors, then you have to go back to redesign the algorithm. So this is redesign the algorithm, and then you do testing again. If there are still some errors, then you go back to redesign the algorithm or revise the algorithm, and then you test it. So if there are no more errors found during the testing, then you now have a working functional algorithm, and that becomes the output of the problem solving phase, the working or functional algorithm, which is also the input to the next phase, which is the implementation phase. So the output of the first phase, which is the working algorithm, becomes the input to the next phase, which is the implementation phase. And the first step here is to rewrite your algorithm into a program by using a programming language. So this time you select a programming language. Say, for example, in our case, we're going to use the C programming language. And so you code the algorithm now as a program. And then this time in the testing, you use a compiler. In our case, we're using the dev C++ and of course a computer. This part here is again a cycle, because when you compile your C program using a compiler like the dev C++ IDE, when the compiler or the computer reports some errors, then you have to revise the code. Okay, you correct those errors, and then you run it again, you compile it again to check if there are no more errors. If there are still some errors, then you have to go back to revise or correct the errors, and then you test it again. So once there are no more errors, then the output of the implementation phase is the working functional C program. So in summary, in the two phases of program design process, which are problem solving phase and implementation phase, the input again to the problem solving phase is the programming problem, and the output is the working algorithm. For the implementation phase, the right broken box, the input is this one, the working algorithm. So for the implementation phase, the input is the working algorithm, which is coming from the problem solving phase, the output of the problem solving phase. And the output of the implementation phase is the working or functional program. We have here three terms: top-down design, stepwise refinement, and divide and conquer, which describe the process of designing an algorithm by breaking down the big task into few subtasks and then continue to decompose each subtask into much smaller subtasks and so on until the resulting subtasks are in their smallest or simplest form. Now, I believe I described this process to you already in one of the previous video, but we will just have to review this time. So again, we are given one programming problem, and since this is a big problem and complex, the way to solve this is to divide it into subtasks, and then once they are in their smallest or simplest form, you conquer each smallest subtask. So first you divide it into two maybe, and then you divide it into 4, so this becomes 4, and then you continue decomposing until the resulting problem is now consisting of many small pieces. Each of these pieces is in its simplest form that you cannot decompose it any further. And after that, once all the pieces are in their smallest or simplest forms, then you conquer or you solve each one. And when you have solved each smallest piece or task, it is equivalent to having solved that one original big problem. So that is what we call top-down design, stepwise refinement, and divide and conquer. So this is the most familiar term for that. Another term we have here is iterative enhancement. Iterative enhancement refers to the process of first designing a simple working correct program, and then you add features and refinements or beautification later. So say for example, if your problem is to write a program to compute the area of a circle given as input to the program the radius. So your first goal to solve the problem is to identify what are or what is the necessary input. So you identify the input to be the radius, and then what is the process? The process is to use the formula area is equal to 3.1416 times radius, right? Because that is the formula for computing the area of a circle, pi r square. Remember, in mathematics, that's pi r square. So if we represent area as this variable area, and pi is 3.1416, and then times rad is the radius, and times rad because this is rad square or r square. And then the output is, of course, the area. So this is basically what you need to know to be able to solve the problem correctly or to come up with a simple working correct program. Not that your first concern is to add blinking feature or boldface feature or making it the output the text italics or boldface. That is not your primary concern. Your primary concern is to identify the correct inputs and identify the correct processes and being able to use the correct formula or formulas and identify what needs to be given as output back to the user. So what is the use of beautification of your program, making it very colorful, and all the blinking features and all the alignment? They are useless when the formula is wrong. Okay, so again, in iterative enhancement, your first goal is to design a simple working correct program. Once it is correct, then you can later on add some refinements, some features, some beautification to make it look good to the user. But it is not your primary goal. The next term here is testing and debugging. What are these terms? Debugging is the process of eliminating bugs from a program. What is a bug? A bug is a program error. So testing or debugging is simply the process of eliminating errors from a program. And there are three main kinds of programming errors. First is called the syntax error. Second, the runtime error. Third, the logical error. The syntax error is the most common programming error, and it occurs during compilation, and this can be detected by the compiler. While the runtime error occurs during running time of the program, and this can be detected by the computer. And the logical error, the third one, is an error in the logic of the program. And unfortunately, it cannot be detected by the compiler or the computer. And so, programmers has to be very, very careful when designing the algorithm or the flowchart, which is the solution to the problem, and in rewriting the algorithm into a source code program so that you don't commit any logical error, because logical errors cannot be detected by the computer or the compiler. So what are examples of logical errors? Like you are using the wrong conditions to satisfy something. So if this condition is true, then you do something like that. So error in the control flow, in the execution, in the if-else statement, in the formulas. So it cannot be detected. Now, syntax error, it occurs during compilation and runtime error during runtime. Now, let's recall this figure we have discussed a while ago, the figure to compile and run a program. So again, what is depicted in this figure is how a program is compiled and run. Now remember that when I gave you a demo on running a program using dev C++, what we did first is we compile the program. To compile is to translate the program which is written in high-level programming language and to translate it into low-level programming language. So again, the input to the compiler is the source code or source program, and the output is called the object code or object program. Now, during the compilation of the high-level language program, the syntax errors occur if there are syntax errors. If there are grammatical errors in the program, then we call them syntax errors, and the compiler will report to the user what are those syntax errors. So it is during compilation that syntax errors occur. Since if there are syntax errors, then the object code will not be generated, and so you revise the program and correct all the syntax errors. Once there are no more syntax errors, then compilation is successful and the object code or the object program is generated, which is then further interpreted or translated by the internal system of the computer until the true executable code to the original source code is generated. And this is what I said to you a while ago. This is the one having the file name extension .exe. After compilation, what's next to do? Second is to run or execute. Now, if there are runtime errors that occur, it is during the runtime part of the program or execution of the program. So what will occur during compilation? Syntax errors, if there are syntax errors. What will occur during runtime? It will be the runtime errors. And example of runtime errors is wrong input values, wrong input types. This is a common example of runtime errors. Say for example, if the program is asking for an integer value and instead of integer value, you input a letter, a character, a symbol, not a numeric value, then that is an example of a runtime error. The computer will report to you that there is a runtime error, and what will happen next is your program will terminate immediately. Okay, so instead of finishing to the last instruction, the program will terminate prematurely. And the third logical error, again, as we have discussed, it cannot be detected. Example of a logical error is when you say, if x is greater 0, then display on the screen using the printf method, x is negative. So say for example, this is your program statement. If x is greater 0, then what will you do? If this is true, this is executed, right? According to our if-else, when we discuss flowchart, if x is greater 0, then you execute this. If the condition is true, execute this. So what will appear on the screen as output? X is negative, which is logically wrong, because if x is 5, this would be true and it would say x is negative when in fact 5 is positive. So that is an example of a logical error. Another thing is wrong formula. Like for example, you say area is 3.1416 times radius times 2. Why is this wrong? Because the formula for the area of a circle is pi r square, not 2 pi r. Okay, 2 pi r is the formula for circumference, not area of a circle. And so if you're using this formula, that is a logical error. Now, every programming language has syntax and semantics. Syntax of a programming language refers to the grammatical rules on how to construct a statement or instruction in that language. It refers to the spelling and grammar of a programming language or the format of programming constructs, referring to grammatical rules or the format, how to construct an instruction, a statement in that programming language, while semantics refer to the meaning of the programming constructs or the meaning of program statements. Like for example, the syntax to declare a variable is this one, data type, one or more spaces. After that is the variable or variable list and terminated by semicolon. So when you declare a variable in your program, you could select from 4 atomic data types in C. Say for example, one of that is integer, which is simply int. Int is data type integer, and then you could put 1 or 2 or more spaces, but usually it's just one space, and then say you declare the variable to be x and semicolon. So this one is a variable declaration of variable x, which is type integer. So x being a variable is like a container. So a variable is like a container that holds a value. So if that variable is type integer, like in the case of x, then the value that that variable can hold is also an integer value. So you could say in your program, x set to the value 5 or x set to the value 23. Now, if you have more than one variable of type integer in your program, then you could have a list instead of just one variable. So you would say comma y. This time, you have now two variables, x and y. So if it is a variable list, then you have to separate the variables using a comma. That would be written this way, int x comma y. If there are three, for example, x, y, z, then x comma y comma z and semicolon. There's no more comma after z because z is the last variable in the list. Okay, so this is an example of a variable list. So the syntax is this one, the format or the rule or the format on how to declare a variable, while the meaning or the semantic is the one that I have explained to you a while ago, that the meaning of this syntax is that these are the variables or containers that the program are going to use, and the data type of the values that these variables can hold is this one, which is in our example integer. Now let us discuss a little background of the C programming language. C programming language can be traced from the older programming language which we call BCPL, developed by Martin Richards. And then this was revised, and the new programming language, a revision of this, is called B, and this was developed or invented by Ken Thompson. And after the B is the C programming language, which is a revision of B, and this has some more features that's not in B. And this was invented by Dennis Ritchie in the 1970s. And this was first implemented in the Unix operating system at Bell's. There were some varieties of C programming language, and since there are several varieties of C programming language, they decided to come up with a standard, and that standard C programming language is called ANSI, because ANSI is the committee of people that formalize the standard C programming language. And of course, the resulting standard C programming language, they call it ANSI C because the name of the committee that created this standard C programming language is the ANSI, or that's an acronym that stands for American National Standards Institute. And so they eliminated all the varieties and they adhere to the standard ANSI C programming language. And they require all companies that would develop compilers for C programming language to follow or adhere to the protocols or policies or to the standard of the ANSI C programming language. And so whatever compiler you are using, all the C program you develop in one compiler must run in another compiler because all of these compilers are supposed to follow the ANSI C or the standard C programming language. Now, particularly the C programming language is considered a middle level language. Okay, remember that we have two kinds of programming languages, right? We have discussed that before. The first is high level programming language, and the second is low-level programming language. The high-level programming languages, examples to this is the C language, the Java, the Python, and many others. And one characteristic of high-level programming language is that this resembles human language, okay? Like in C programming language, there are English words, which are human language. While for the low level, easy for computers to understand because they resemble language. But C programming language, although it is considered high-level programming language, is actually a middle-level language because the reason for that C programming language is considered middle-level language is that it contains features of high-level language and also features of low-level language because you could use it to actually manipulate the hardware of the computer, like the bits and the bytes and the memory addresses. A low-level system, and C programming language has that feature to manipulate this. And so it is considered not just high-level but a middle-level language. And it is considered also as a structured language because it can compartmentalize code and data, separate functions. Compartmentalization is the language ability to section off and hide from the rest of the program some information and instructions necessary to perform a specific tasks.